He's literally gonna take
Clear? Right. I don't know that answer.
Go to Family Dollar.
Wherever they got the colored ones would be your best option to find a clear one. Otherwise, Hefty might make a clear garbage bag. Start with them. All right, 3-4, day 1. To discover a formula that tells how fast an object moves if it's spinning in a circle. So we're going to be talking a lot about pulleys and gears and where's my little, oh right here. Yeah, if you watch the orange block, we're going to get formulas that talk about how fast that orange block is moving and how much distance it's covering as it spins around. The whole section is about something that's spinning. And when we talk how fast it's spinning, we're going to talk about how fast the orange block is moving, and we're going to talk about how fast the angle is changing at the center. So there's 2 different velocities we're going to be working with. If that was at all entertaining, I hope so, for your Friday. So, let's take a look at our spinning object. So we're going to watch a point move as it rotates around. And we're going to talk about how quickly the angle is changing. So if I were to ask you how fast you traveled here this morning, what kind of an answer would you give me? 60 what? Miles per hour. I went about 72 miles per hour because I get to travel on 65 mile an hour. So the velocity, you got an idea, it's miles per hour. Miles is a distance per time. So as these objects move, it's the same thing. We probably won't go miles, but maybe we'll go inches per second or feet per minute or whatever it's traveling in. But at any rate, how fast point P moves is its velocity. And how fast theta changes, that's going to be called angular velocity. So when we just say velocity, we're talking like a linear velocity, even though we're not going in a straight line. It's still a distance over time. How fast theta changes is angular velocity. So you just told me your velocity on the way here was some distance over time, miles per hour. Well, now if we take that distance on our circle, that distance is still it could be like inches or feet, but it's in that circular pattern. We just took a quiz on this stuff. What did we call this curved distance? Arc length. So for us, our formula, you just discovered it, our distance is the arc length traveled in the given time interval. Your quizzes were very, very good. Quite impressed with them. So I know you know how to find arc length. What's our process to find arc length? What 2 things do you need to know? Radius and the angle measure. Because it's a fraction of the circle. We're just going to have multiple circles. So it's the fraction of the circle, which is your angle measure. What do you divide the angle measure by to get your fraction? Or 2 pi, depending on what it's given in. You had one of each on your quiz. Could be over 360 if that's in degrees, or 2 pi if it's in radians. That gets you your fraction. Then what do we multiply that by? 2 pi r. And now to turn that into a velocity, we're just going to divide all of that by time. So that whole top part is still just how you found f, arc length. And now we divide by the time interval. There's going to be one more formula for it, so leave a space. If you got space here, we're going to have two formulas for it in a minute. Okay, angular velocity. So if we talk about how fast the angle is changing, what kind of units could we have on angular velocity? Just a general sample of what angular velocity could be in terms of units. What do you think?
Degrees per second.
Degrees per second, degrees per minute, degrees per hour, what else? That's one way. What other kind of angles do we have? Besides, Jimmer? Radians per minute, radians per second. Seems like we should be able to have two different angular velocities. They don't use the degrees. I don't know why. It's still an angular velocity, but our book doesn't do anything with degrees per time. So when they say find angular velocity, it's always going to be radians per time. So, oh, we have a nice symbol for angular velocity, another Greek letter, lowercase omega.
Hey, Schwartz,
Yeah.
when you have a second, Mr. Quigley has a good math question for you.
Okay. It'll be a little while.
Okay.
Angular velocity, W, I like to call it butt cheeks. Well, it's a good Friday, isn't it? Okay, angular velocity is always going to be how many radians it passes through per time. Which gives us theta over t, but that has to, every time it's just implied it's radians. Even though degrees per minute and degrees per second to me is an angular velocity, we'll go that route. So what happens is, with this formula here, and you don't even have to, I'm just going to show you where it comes from. You don't have to know the development of it, so I'm just going to show you real quick, and we're going to fill it in. If we take this formula here, our velocity, and if I go with the radian version, theta over 2 pi times 2 pi r, divided by time. The 2 pi's are gone. So I get linear velocity is the radians times the radius divided by time. Well, we just had the radians over time equals W. So another way to get linear velocity is angular velocity times r. So on here, another way to get linear velocity is to have W times R, butt cheeks times R. So you're going to have two versions for linear velocity, only one for angular velocity. Okay. With that, we get right into our example. And all it is plug and tug into these formulas. Pretty easy day. Number one, we have a pulley that turns 2 pi over 5 radians in 10 seconds. Can you find its angular velocity? And the best thing you can do for yourself to get yourself ready for the story problems next week is to write down the symbol that goes with each piece of information. So because I'm giving you the radians, what symbol have we been calling radians? What symbol in our formula is where we put the radians? Is it going in here, here, or here? Or the theta, it's the theta. So this is your theta value. 10 seconds is a time value. There's your t. And it's asking you to find angular velocity. What's our symbol for angular velocity? Everybody's friend? Butt cheeks. There we go. So now you know exactly what formula to use. W beta over time. We're just going to plug and chug. So all we're doing today is plug and chug. This is the easy one because we don't have to work any backwards here. We got 2 pi over 5 divided by 10. You've got a fraction within a fraction. We're going to stay exact. How do I take a fraction and divide by something that could be a fraction? Multiply by the reciprocal. So see this as a second fraction. And it's just multiplied by the reciprocal. Junior high fraction. So 2 pi over 5 times 1 over 10. Can do a little reducing. Pi over 25. And what should be our labels? Story problems always get labels. What kind of units if this is angular velocity? Radians per second. Okay, number 2. Got our pulley again. Moves at 3 pi over 4 radians per minute. It travels for 6 minutes. Through how many radians did it turn? Okay, so you see something spinning for 6 minutes. We want to know how many radians it passed through, because every time it makes one full rotation, that's 2 pi. So we want to be able to figure out how many radians it went through. Okay, so again, it's all about getting the letter to match this. Because this is radians per minute, what symbol goes with the 3 pi over 4? Radians per minute. That's some kind of a velocity. It's butt cheeks. Glad it's still funny. Usually it's only funny like the first 2 times. Okay? So that is angular velocity. Be able to identify that by the label here. Travels for 6 minutes, that's the time. It's asking for how many radians. What's our symbol for radians? It's an angle measure. That's our theta. So we're trying to find theta. So we just go right, there's only one formula that has these 3 symbols in it. So W is the 3 pi over 4. Thetas are unknown. And then 6. How do you solve for theta? Just multiply by 6. Times by 6. And I'll make it 6 over 1 so you can line stuff up. 6's are gone. We'll reduce here. 2, 3. Multiply tops. 9 pi over 2. Radians. Okay, our last pulley one, I think. Yep. We've got our pulley moving at pi over 32 radians per minute. It travels through 3 pi over 8 radians. How much time has passed? So again, it's identify with the correct symbols, and then it's find the formula that works with those symbols. We haven't left one formula yet, but okay, I see radians per minute as my label. That's telling me the pi over 32 is W. Travels through 3 pi over 8 radians, just radians, that's an angle measure, that's our theta. How much time? Okay, same formula. Radians over time. So the W is pi over 32. Theta is 3 pi over 8 over the time, which we don't know. The algebra on this one catches about half the people. I want you to try some algebra on your own, see what you get for T. I want you to just try something, and then if you get it wrong, we'll go back and I'll show you. But try some algebra on your own. If you were stuck, if this was your SAT and you had to solve for T, what would you do? Would you know the algebra to get you to the correct answer? Try something. Because there are like 4 different things roads you can travel down to get there. Lots of ways to screw it up though, too. Any luck getting to 12? Okay, we got some. You got 1/12. That's what happens. Right there, exactly it. I guess I kind of want to know what you did, so then I can... So he's going to tell us the wrong way, but we're going to see why. All right, go ahead, Brody. What'd you do first?
I tried to divide like 3 pi over 8.
Divide 3 pi over 8, which means multiply by 8 pi over 3.
Yeah.
Okay.
On the other side.
That's not wrong. So don't do this, because there might be an easier way. So you times by 8 pi over 3, so times by 8 pi over 3. That gets rid of that. Okay, so that's gone. That's all gone. So what you have left over here is still 1 over t, or t is still trapped in the bottom. See it? This 1, 4.
I had the 8 pi and 3/4 as well.
Well, you didn't divide by that then, did you? What'd you do?
I just like took the 3 pi and 8 and just...
Oh, I put the pi in the wrong spot. 3 pi. I just put that in the wrong spot. 3 pi. That's my bad.
Yeah.
Okay, so that's good. The pi's are gone. So you had, let's see, over here you would have 1/12. But that's not t, that's 1 over t. So at this point, all you've got to do is take the reciprocal of this side and the reciprocal of this side, and you have it. So that would work. Okay? Let me go back. Pi over 32 equals 3 pi over 8 over t. Jimmer, what'd you do?
First I multiplied by t on both sides.
That's perfect, because then that gets your t out of the denominator. Times by t, times by t. All right, good. Then what?
And then I multiplied both sides by 32 over pi.
Perfect. You multiply by the reciprocal here, leaving the t, so times 32 over pi times 32 over pi. So the pi's cancel. That all leaves t, and then 8, 4, 12, what? What label did you put on it?
Minutes.
Minutes. How'd you know it was minutes?
Because it says that it's perhaps moving at radians per minute.
Radians per minute, so our time interval is minutes. Or you didn't put a label and you get a -1. How am I going to pull out that one? That's you. Alright. That. got our pulley. Number 4. We've got our pulley. Moving at 18 feet per second. The radius is 3 feet, the big pulley. Find angular velocity. So again, it's knowing what each piece of information represents. Because the 18 is feet per second, what letter is that? W is radians per second. This is feet per second, kind of like miles per hour. It's a velocity, but which velocity is it? The other one, the linear velocity, it's big V. This is big V velocity, not angular velocity. See the difference? Last one was radians per minute, that's W. Any kind of distance over time, like miles per hour, feet per second, meters per minute, those are all big V's, linear velocities, even though things are going in a circle. Radius is 3 feet, there's our R. Asking you to find angular velocity. Angular velocity is W. Do you have a formula that has V, R, and W in it? Gave it to you at the beginning, it's the new one. V equals R times W or W times R, I don't remember which way I wrote it. There's your formula. Now let's plug and chug. So big V is 18. W is W times 3. Divide. The algebra is super easy now. It was deciding which formula to use. 6 what? That would be a theta. This is a velocity per second. Radians per second. Radians per second. All right. Okay. If you are given the number of times something rotates, the number of rotations per time. So it spins 15 times per minute or 20 times per hour. It's kind of a velocity. And what we want to go to, what we want to call this is almost butt cheeks. Almost angular velocity. Because angular velocity is radians per time. But if I know how many times it's spinning, can I turn that into the number of radians? How many radians in one spin? 2 pi. So if I said it spun at 4 rotations per minute, how many radians would that be per minute? They're nice. Come in. They won't say anything. See, they're proud of you. Nice job. Well, whisper it to me.
No.
What?
Do you have notes for the section?
Do I have the notes for the section? No, but you could find someone else in the class and borrow. Okay, good luck with that. Where's your folder with all your notes in it?
Oh, my back in
No.
Backpack is in the eyes.
Oh, that's a problem. See, you guys have all your notes in your notebook, but some people just aren't quite there yet. They need a little help. I give them a folder, I don't know. I do what I can. Anyway, back to this. So, if you see rotations per time, we're going to call that almost W. It just means we got to fix it and get it to radians per time. Okay? Because the number of rotations multiplied by 2 pi will give you your radians. As long as that makes sense. Every rotation is 2 pi radians. So if we just take the number of rotations, multiply by 2 pi, we'll know how many radians. We're not going to change the time interval. It'll just be per that same time. So, knowing that, can you find the angular velocity of the second hand on a clock? The one that counts the seconds? So notice, no information given to you because we know how a clock works.
Is that supposed to be a 0 next to radian?
No, it's a scribble out. I was going to do a theta there, then I wanted to say radians, so that. Okay. So we're looking for angular velocity. Angular velocity. I need radians per time. I could go degrees first. So take a look at that second hand on the clock, the red one. Okay. If I asked you, how long does it take the second hand to pass through 90 degrees?
15 seconds.
Okay, so we could turn that into a velocity. 90 degrees takes 15 seconds, so I could divide 90 by 15 and get degrees per second. Easy. That's an angular velocity, except we want radians. So we can look at a full rotation. How many radians in a full rotation? 2 pi. How long does it take second hand to go around? Turn that into a velocity. 2 pi radian takes how long? 60 seconds, so it's pi over 30. What's my symbol? Or label, I mean, not symbol. Radians per second. So the second hand, we've got our angular velocity in per second. Let's go minute hand. Find the angular velocity of the minute hand on a clock. I'd just like to go with the 1 full rotation. We could do the quarter rotation and use pi over 2, but I think it's easier just to use the full rotation. So let's look at the minute hand. That's the one that's on the 8 right now. Okay. Full rotation is 2 pi radians, but how long does it take? 60 minutes. So when you reduce it down, it kind of looks the same, pi over 30, except the label is what's going to make it way different. Radians per minute. And then you've got your hour hand. Can you find the angular velocity of the hour hand? So let's look at 1 rotation of the hour hand. Find the hour hand. How long before it's right back around there again? 12 what? Hours. Usually people want to say 60 minutes, but in 60 minutes, where's it going to be at? Just 1 click up. It's got to go all the way around the whole clock. It takes 12 hours. Tonight is when it's going to be back there. 12 hours. So we get pi over 6 radians per hour. see. These are story problems. I think I'm gonna save those for Monday. Okay, we're done. Page. Yeah, it's 30 minutes. It's good enough. Let's see. I need.
I don't know how this 5K is gonna go for Paige.
Oh yeah, she said she wasn't running in the rain.
I know, that's what she said.
Let's see. What have we got here? So I think it's supposed to be done raining by like 3 though.
I know, that's what I'm hoping. I'm hoping it'll do that.
Let's see. Plan book. Here we go. Trig. Here we go. Page 134. 5 through 23. Pick up the odds. And then 27 to 29. I think I did enough for you to be able to do all that. Monday we'll start the story problems.